Okay, here's two different examples to help you see what's going on. And then we'll get back to this one later. Okay, suppose f of x equal this, the definite integral from 0 to x of t squared dt. Let's say you just had to do this like you do any other definite integral. You'd find an antiderivative for this, which would be 1/3 t cubed. You'd evaluate from 0 to x, which would be 1/3 x cubed, because we put x in for this t, minus 1/3 of 0 cubed, because we put 0 in for the t. Of course, this is just a 0, equals 1/3 x cubed. Now, if we have to find the derivative of this, we'd use the power rule, and we just get x squared. After you do that a few times, you realize that all you have to do is substitute this x for t, because the derivative of this term, whatever, if this had been a 1, this would have been a constant term out here, like minus 1/3, and when you took the derivative, it would go to 0. Now here's one that's slightly different. Suppose this upper limit had been a function of x, like 2x minus 1. If you go through the same process, there's the antiderivative from 0 to 2x minus 1. You put this in here for t, minus, well, let's just change this to a 1 this time. Put a 1 here. You'd get 1/3 of the quantity 2x minus 1 cubed minus 1/3. Now when you take the derivative, of course the derivative, the minus 1/3 is still 0. But here we'd have to apply the power rule. 3 times a third is 1. Reduce the exponent by 1, but then you have to apply the chain rule, multiplied by the derivative of the inside. And now, do we see a way to think about this? Well, we find the antiderivative of t squared and then take the derivative, we're back to t squared. So we just have to put 2x minus 1 in for t. But if this is a function of x, we have to multiply by the derivative of that, because that's like applying the chain rule. So let's see if we can do this here. We've got the integral from 0 to x cubed of sine of t to the 4th dt. Well, we don't have to find the antiderivative of sine of t to the 4th, because then we're going to end up taking the derivative of that. We'll be back to where we started. But we'll be evaluating from 0 to x cubed, so we have to put that in for t, but then we have to multiply by the derivative of that function of x. So here's what the derivative of f prime looks like. There's the original integrand. We're going to put x cubed in for the t. So we're going to have x cubed to the 4th power but then we have to multiply by the derivative of the inside when we take that derivative of big F, which is 3x squared. So we would probably in the end write this way, 3x squared sine of x to the 12th. And if this had been a constant other than 0, like a 2, when we'd have some term out here that we would put 2, well, minus some term where we put 2 into the antiderivative, but then when we take the derivative, that becomes a 0. So there's your answer right there. That is the derivative of this function. Okay, hope that cleared some things up for you. If you have any questions, post a comment.